Okay, we're going to try a slightly different type of problem here, just because I don't have this one in our homework at all. But here's the equation we're trying to find up here. And you'll notice that you don't have a bunch of equations below, but rather we have a bunch of standard heats of formation. That's what this little symbol here means, standard heat of formation. F obviously is formation. And what that is that's just the energy change to create 1 mole of NH3, for example, from its elements in their standard states. So to make NH3, okay, NH3, I'm going to use N2, which is a gas, and I'm going to use H2, which is also a gas. Okay, but I have to use the right amounts to make 1 mole. Well, that means I'm going to have a half mole of N2 and 1.5 moles of H2. Okay, so that gives me the right amount. The change for this reaction, it tells you, is negative 46. So basically what we're going to do then is I'm going to quickly rewrite all of these in terms of their standard heat of formation. Basically write these guys like this one here. So I'm going to do it really quickly, and I'll come back and show what I have. Okay? Boom! Just like magic, there we are. Okay, so again, for each of these, I'm just forming 1 mole of my product, because each of these have units of kilojoules per mole. Okay, so there we have it there. So those are the 3 reactions I'm going to use to find out this top reaction up here. I just have to kind of rearrange a bunch of things. You'll notice I didn't do one for fluorine because the enthalpy of combustion, or the heat of formation, sorry, for fluorine is 0, because fluorine F2, that's its natural state. The whole point was to make these guys here from elements, their constituent elements in their natural state. F2 is already in its natural state, so there is no energy change to make it. It already is there. Okay, so we're going to take this guy here. That didn't work. Try it again. There we go. And move this towards the bottom here. This will be my starting point. Okay, and using that first reaction, I can see that I can create NH3 from half mole of N2 and 3/2 moles, or 1.5 moles of H2, and that has a change of negative 46. Okay, but I also have to have, need to have 3 F2s here so that they appear right there as well. Okay, so that's good there. I need to make some HFs, but I don't want to make 1, I need to make 3. So to do that, I need to have, let's see, 3/2 H2s plus 3/2 F2s. And that'll produce 3 HFs. Okay? But I also need to have an NF3 there to make sure I get my NF3 there as well. Okay? And because I multiplied everything by 3, this becomes negative 269 times 3, so negative 807. Okay, all I gotta do now is connect this guy here. Okay, I see that I'm gonna make NF3 somehow using this equation here. I need to have a half mole of N2. There it is there. I need 1.5 moles of F2. I have 3, so I take away 1.5, and I have 1.5 left over. So again, everything balances out. Okay, and this is negative 114. Okay, so to find X, all right, I can go, let's see here, I can either go, it's going to be negative 114 plus negative 807. That's the same as doing negative 46 plus X. And you can get the answer that way. So there's an example for you, just like we did today in class. Hope that was helpful.